Hi, welcome to today's numeracy tutorial. Our learning objective today is to continue to find equivalent fractions. So far, we know that shapes of equal size can be split differently to show different fractions. We also know that these fractions can be equivalent in size. For example, 2/4 is the same as 1/2. We also know that 1/3 is equivalent to 2/6. We examined a number of examples of equivalent fractions in our previous tutorial. You can always go back for a refresher if you would like. Today, we will continue to develop our mathematical understanding of equivalent fractions by learning how to identify equivalent fractions on number lines and a fraction wall. More of that to follow, because as always, we'll get ready for our lesson with a 5-question brain gem. Get ready to warm up. Here are your 5 questions. Pause the video and have a go. Question 1 asks us to examine the illustration and complete the equivalent fraction. We can see the bar has been divided into 8 equal parts and 6 of those have been shaded. What other fraction can we see? 6/8 are equivalent to 3 parts of 4. Can you see that? So the answer is 3/4. Question 2 asks us to calculate the area of the shape. We must be very careful not to mix up the perimeter and the area. The perimeter is the distance around the rim of the shape. The area is the space the shape takes up. The area is the measure of the space on the inside of the shape, and we can see this shape has an area of 9 squares. Question 3 is a multiplication calculation. The product of 4 and 17 is 68. Well done to you if you calculated that correctly. If you didn't, check and see if you remembered to include your exchanged tens. Question 4 gives us practice of identifying equivalent fractions in shapes. We can see the bottom bar is split into 3 equal sections. It shows thirds. The top bar has 9 equal sections. If we record these onto the bar, we can see the equivalent fractions. Question 5, as always, is our time question. What time is it? Well, the minute hand is pointing to 10. We can see there are 10 minutes until the next hour. It is 10 minutes to 3. As a digital time, we write the current hour, which is 2, and the minutes past this hour, which is 50. So the digital time is 2:50. Now we are ready to focus on our learning objective. Today we are continuing to develop our understanding of equivalent fractions. We are going to learn to use a number line and a fraction wall to find equivalent fractions. Let's go. Here's a number line from 0 to 1. If I draw a line halfway along the number line, I have 2 equal sections on either side of the line. Counting along the line, 1 section is a half, and 2 sections are 2 halves, which is the same as 1. If I take another number line, and this time divide it into 4 equal sections, well, 1 section is equal to 1/4. 2 sections is equal to 2/4. 3 sections are 3/4, and 4 sections are 4/4. Which is the same as 1. I can take another number line and divide it into 3 equal sections. This time the number line is showing thirds. 1 section is 1/3, 2 sections is 2/3, and 3 sections is 3/3. Again, this is equivalent to 1. Counting along this number line, which has been divided into 9 equal sections, would look like this. Have a closer look at these number lines. What is the same about them and what is different? Pause the video and have a think. You might have noticed that all the number lines are the same size. They all show from 0 to 1. You might also have noticed that this same line is showing different fractions. We have shown the same number line split into halves, quarters, thirds and ninths. Here's a bar that has been divided into 4 equal sections. Each section is therefore 1/4. Here's a number line beneath our bar, and we can see that if we have no sections of the bar shaded, well then we would have a 0 at the start of the number line. If one part of the bar is shaded, then we move along the number line to 1/4, shading 2/4 of the bar, and we can count to 2/4 on the number line, shading 3/4 of the bar, and we can count to 3/4 on the number line, and finally shading 4 parts of the number bar. Well, we can move along our number line to 4/4, which is the same as 1. If I then divide each section of the bar in half, I will have 8 sections, and each section is 1/8. If I shade 2/8 of the bar, I can count to 2/8 on the number line, which is in the same position as 1/4. So 2/8 is equivalent to 1/4. If I shade 2 more 8s, then I move to 4/8 on the number line, which we can see is equivalent to 2/4. Shading 2 more 8s means we have shaded 6/8 of the bar altogether. And on the number line, we can write 6/8. 6/8 is equivalent to 3/4. Then, if we take our bar that has been divided into 4 equal sections and divide each section into 3 more equal sections, then we will have a whole bar that is divided into 12 sections. This bar is now showing 12ths. Each section is 1/12. If we shade 3 of our 12ths, we can see that the position on the number line is the same as that for 1/4. 3/12 is equivalent to 1/4. Then if we shade 3 more 12ths, we have 6/12, which on the number line is in the same position as 2/4. 6/12 is equivalent to 2/4. We can continue shading in 3/12 and finding the equivalent fraction on the number line. 9/12 is equivalent to 3/4. We can do something similar with a number line. Let's move our fractions up onto the bar to show equivalent points on the bar and the number line. If we divide each section of the number line further into 4 equal sections, we would have 16 sections altogether. So each section would be equivalent to 1/16. We could use our number line to count along in 16ths. 1/16, 2/16, 3/16, 4/16. Notice that 4/16 is equal to 1/4. If we shade a second quarter on our bar model, I can show that this is actually equivalent to 8/16. Pause the video and have a think. What is 3/4 equivalent to on the number line? Did you see that 3/4 is actually equivalent to 12/16? If we take a look at quarters, 8ths, 12ths and 16ths together, we can see the equivalent fractions more easily. Notice how 1/4 lines up across each of the bars and number lines to show 1/4 is equivalent to 2/8, and it's equivalent to 3/12, and it's equivalent to 4/16. If we take our number line and divide it into 5 sections, we would be showing fifths. If we take one of those fifths and divide it by 2, well, each of the sections are now tenths. We could extend this the whole way up the number line and record the tenths underneath. Notice how 5/5 is equivalent to 10/10. They both are equal to 1. We can see that 1/5 is equivalent to 2/10, and actually 4/5 is equivalent to 8/10. Now let's look and see what happens if we take the same number line and again divide it into fifths, but this time we divide each one of the sections by 3. So now our number line shows 15 sections, or 15ths. Notice this time that 1/5 is equal or equivalent to 3/15. 3/5 will be equivalent to 9/15. Again, take special notice what happens to the numerator and the denominator. Can you see a pattern? We will take this further at a later stage, but it's worth a little thought. Here's a bar model, and it's been divided into 2 equal sections. One half is shaded. Next we have a bar model, and it's been divided into 4 equal sections, or quarters. When I shade in 2 of the quarters, we can see it is equivalent to 1/2. If we take another bar model and divide it into 6 equal sections, or sixths, we can shade half of the bar to see that that is equivalent to 3/6. This time the bar has been divided into 8 equal parts, showing eighths, and it would take 4/8 to show a half. So using the bar models, we can see that 1/2 is equivalent to 2 quarters, and that's equivalent to 3/6, and it's equivalent to 4/8. We can take the bars showing different fractions and compare them to find equivalent fractions. This is called a fractions wall. It begins at the top with one whole bar. Then it has a bar underneath divided into 2 equal sections, or halves. Then the bar beneath that is divided into 3 equal sections to make thirds. Below that, the next bar is divided into 4 equal sections to make quarters. The next bar has 5 equal sections to make fifths, and so on all the way down to twelfths. If we want to find an equivalent fraction, for example 5/6, we must first find 5/6 on the fraction wall. The yellow bar shows 6. We are interested in 5/6, so we've got to count across. 1, 2, 3, 4, 5. Now we can then look down the fraction wall to see if any other bars line up exactly with 5/6. You might want to use a ruler or a piece of paper to help you with this in the beginning, because the lines have got to line up exactly. If we look straight down from 5/6, we can see that our line corresponds to a line on the orange bar, the 12ths bar. Counting along this orange line, we can see that there are 10 twelfths. So 5/6 are equivalent to 10 twelfths. Now it's time for you to have a go. Use this fraction wall to find equivalent fractions for 2/5, 2/3 and 6/8. Pause the video and have a go. First we find 2/5 on the fraction wall. Then we use a straight line to find any fraction bars with a line in the same position. Here we can see that the green tenths bar has a line in the same place. There were 4 tenths before the line, so 2/5 is equivalent to 4 tenths. For our second example, we start in just the same way by finding 2/3 on the fraction wall. Then using a straight line, we look for equivalent fractions. We can see that 4/6 is equivalent to 2/3. However, if we continue the line down, we can see that our line also meets an equivalent fraction on the blue 9ths bar. So 2/3 is also equivalent to 6/9. But that's not all. If you continue the line down even further, we can see that it also meets an equivalent fraction on the orange line, the 12ths bar. So 2/3 is also equivalent to 8/12. In our third example, we start just as before, by finding 6/8 on a fraction wall. As before, we use a straight line going down, and we can see that 6/8 meets an equivalent fraction on the orange 12ths bar. 6/8 is equivalent to 9/12. But that's not all. If we extend our line upwards as well as down, then we can see that we also meet an equivalent fraction on the quarters bar. 6/8 is also equivalent to 3/4. That brings us to the end of our tutorial. Today we got lots of examples to see how we can use number lines and bar models to show and see equivalent fractions. Now it's time to get more practice during your independent task, putting what you've learnt to use. Good luck!